March 14, 1945. The air over Wright Field, Dayton, Ohio, carried the damp chill of a lingering winter, thick with the smell of wet asphalt and high-octane aviation fuel. Inside the cavernous, steel-ribbed expanse of Hangar 4, a different kind of cold emanated from the machine at its center. Arthur Jensen, a senior aeronautical engineer on loan to the USAF's T-2 intelligence unit from the National Advisory Committee for Aeronautics, walked a slow, deliberate circle around the captured Focke-Wulf FW-190A-8. The aircraft had arrived just days before, a ghost shipped in pieces from the European theater, its mottled gray and green camouflage a stark, alien presence against the olive drab and polished aluminum of the American planes that were the base's daily bread. The black cross on its fuselage and the stark, angular swastika on its tail fin were more than just markings. They were symbols of a design philosophy, a strategic doctrine, and an enemy that, while collapsing, was still lethal. This aircraft was pristine. It wasn't a wreck salvaged from a battlefield, but a nearly intact prize, forced down on a freshly captured airfield near Saint-Dizier, France, by a fuel pump failure. Its pilot was now in a POW camp, and his machine, work number 737913, was here, in the heart of American air power research, ready to give up its secrets. Jensen wasn't a combat pilot, a fact for which he was quietly grateful. His value lay not in his reflexes, but in his mind. With 12 years of aeronautical design experience, a degree from Caltech, and a mind that saw stress loads and airflow patterns where others saw only wings and rivets, he was here to do something no frontline Allied pilot ever could. He was authorized to dissect this machine, to test it, to fly it until its wings came off if necessary. The report he and his team were about to create would become a seminal document, a quiet but profound postmortem on the Luftwaffe's premier radial engine fighter. The context of this evaluation was unique, a subtle but critical departure from the analyses conducted by America's allies. Since the war began, the British at Farnborough had tested captured German aircraft with a desperate urgency, seeking any weakness, any small performance gap that could be exploited in the deadly calculus of aerial combat over the Channel. The Soviets, pragmatic and perpetually behind, tore enemy technology apart to copy it, to reverse engineer its strengths into their own machines. But here at Wright Field, in the spring of 1945, with Germany's defeat all but certain, the mission of the newly formed T-2 intelligence unit, the precursor to the famed Operation Lusty, was different. It was not about propaganda. It was not about finding a magic bullet to win a dogfight tomorrow. It was about a cold, dispassionate, and exhaustive technical understanding. How did the machine work? What made it so effective? And most importantly, what were its true, unvarnished limitations? The answers would not only help mop up the final months of this war, but would shape the design of American jet fighters for the next. The United States Army Air Forces had allocated a significant portion of its intelligence budget, running into hundreds of thousands of dollars, for this program. They were no longer just reacting to enemy technology, they were systematically harvesting it. This FW-190 wasn't just a war trophy, it was a data set, a complex equation of power, aerodynamics, and metallurgy waiting to be solved. And Jensen was the man chosen to solve it. On the morning of March 15th, Jensen and his team began the dissection. The large, clamshell cowlings were unlatched, swinging open like the carapace of a giant beetle to reveal the heart of the beast, a BMW 801D-2, a 14-cylinder, twin-row, air-cooled radial engine. It was a masterpiece of compact engineering, a brute-force solution to the problem of horsepower, putting out a formidable 1,700 horsepower for takeoff. Jensen ran a gloved hand over the cooling fins, his eyes tracing the intricate plumbing of oil and fuel lines. He was immediately struck by the Commandagerat, a device his team had only read about in fragmented intelligence reports. It was essentially a hydromechanical analog computer, a clockwork brain that automated the engine's management. While American pilots, like those in a P-47 Thunderbolt, juggled separate levers for throttle, propeller pitch, and fuel mixture, the German pilot had only one. He pushed the throttle forward, and the Commandagerat did the rest. It was a brilliant piece of engineering, designed to reduce pilot workload in the heat of combat. For 3 days, the hangar was filled with the metallic scent of lubricants and the clean, sharp sounds of specialized tools. Jensen's team worked with the precision of watchmakers, disassembling key components, measuring tolerances with micrometers, and taking material samples for metallurgical analysis at the Wright Field Technical Data Laboratory. Every part was photographed, cataloged, and laid out on clean, white sheets. Jensen's preliminary notes filled a thick binder, page after page of diagrams and specifications. But on the 3rd day, while examining the components of the main landing gear assembly, he found the first sign of trouble. It was subtle, almost imperceptible to an untrained eye. A trunnion pin, a critical load-bearing component, showed minute tooling marks, evidence of being finished by hand rather than by a precision grinder. He brought his micrometer to bear. The design specifications, recovered from a separate cache of captured documents, called for a tolerance of no more than 5/10,000ths of an inch. His measurement showed a deviation of nearly 3/1000ths. A tiny discrepancy, but in a world of high-performance aircraft, it was a chasm. He found more inconsistencies: a forging that showed signs of crystallization from improper heat treatment, a locking mechanism where the fit was just a little too sloppy. Jensen understood immediately what he was seeing. This wasn't just a single faulty part, it was a symptom of a systemic disease. It was evidence of production under immense pressure, of quality control standards being abandoned, of specified alloys being replaced with whatever was available. He imagined the factory in Marienburg, likely staffed with forced labor, being hammered by Allied bombers day and night. Germany in late 1944 wasn't building Focke-Wulfs to the original design standard. It was building them with whatever parts it had, however it could, just to get them to the front. The legendary German dedication to precision engineering was cracking under the strain of total war. The real test, however, was yet to come. The aircraft hadn't even left the ground. March 22, 1945, dawned clear and cold. Major Jack Reynolds, a veteran P-47 pilot with over 1,500 flight hours and 2 tours in the European theater, swung himself into the FW-190's cramped cockpit. Reynolds was the physical embodiment of the Thunderbolt he'd flown, broad-shouldered, confident, and with a reputation for being almost impossible to rattle. He'd tangled with 190s over the fields of France and Germany, respecting them as dangerous, agile opponents. Now he was about to fly one. "Just bring her back in one piece, Jack," Jensen said, leaning on the cockpit sill. His tone was calm, but his eyes were intense. "And tell me everything she does. Everything she feels like." "Don't you worry, Art," Reynolds grinned, his voice muffled by his oxygen mask. "I've danced with these ladies before. Time to see if I can lead." At 10:05 a.m., with a cough of black smoke, the BMW 801 roared to life, settling into a deep, throaty rumble that vibrated through the concrete of the ramp. Reynolds completed his pre-flight checks, the German labels on the instruments a strange counterpoint to the familiar routine. He gave Jensen a thumbs up, released the brakes, and began to taxi toward runway 22. What happened next stunned the ground crew. As Reynolds advanced the throttle, the Focke-Wulf immediately and violently swerved to the left. The torque from the massive propeller was trying to twist the entire airframe. Reynolds, expecting some torque, was caught off guard by its ferocity. He stomped on the right rudder pedal, the tail swinging back into line, but as he added more power, the plane veered again, even more sharply this time, its left wingtip threatening to dig into the tarmac. The screech of tires filled the air. With a curse, Reynolds chopped the power, applied the brakes, and aborted the takeoff run. He taxied the bucking, unruly machine back to the hard stand, the engine sputtering into silence. He unstrapped his helmet and climbed out, his face a mask of frustration and disbelief. He walked over to Jensen, pulling off his leather gloves. "Art, that thing is a monster on the ground," he said, his voice tight. "4 words for you. This aircraft is unstable." Jensen nodded slowly, making a note on his clipboard. He wasn't surprised. His team spent the next hour crawling over the landing gear again. They checked the alignment of the wheels, the tire pressure, the tailwheel locking mechanism. Everything was, technically, within specifications. But Reynolds was adamant. It's not a mechanical fault, Art. It's the design. The gear is too narrow, and that big engine just wants to throw it in a circle. An hour later, they tried again. This time, forewarned was forearmed. Reynolds applied power with excruciating slowness, his right foot holding constant, heavy pressure on the rudder pedal, dancing on the edge of control. The FW-190 crabbed and weaved down the runway, a wild horse resisting the bridle. Finally, with enough speed, the rudder became effective, and Reynolds managed to keep the nose straight just long enough to lift off. The flight lasted 34 minutes. Once airborne, the aircraft was transformed. The beast that had been so clumsy on the ground became a creature of pure grace and power. Reynolds put it through a series of basic maneuvers, climbs, dives, and graceful, sweeping turns. The plane's roll rate was astonishing, far quicker than his P-47. When he landed, taxiing carefully back to the hangar, his report was brief but revelatory. "Incredible rate of climb," he summarized during the debrief. "Controls are heavy but very responsive. The roll rate is well, it's a revelation. But visibility over that long nose on the ground is terrible. And that tendency to swerve on takeoff and landing is persistent. You have to be on the rudder every single second. Take your eyes off the ball for a moment and it'll kill you." Jensen listened, a sense of dawning comprehension on his face. He finally understood a crucial piece of the puzzle. The Focke-Wulf FW-190 was not an easy aircraft to fly. It demanded constant, expert skill from its pilot just to get it into the air and back down again safely. This wasn't a defect in the traditional sense. It was a fundamental design characteristic. The combination of a powerful, high-torque engine, a massive propeller, and a narrow-track landing gear that retracted inward for aerodynamic cleanliness made the plane inherently unstable on the ground. Experienced Luftwaffe aces, with thousands of hours, would have compensated for this instinctively. But for a new pilot, fresh from training, this unforgiving behavior was a death trap. There it was, the first critical flaw. The FW-190 was lethal to novices, not in combat, but on the runway of their own airfields. Jensen immediately put in a request through T2 channels in London for any available Luftwaffe accident data. Within days, fragmented reports, painstakingly compiled from recovered German documents, began to filter back. The numbers were staggering. Between 1942 and 1944, it was estimated that as many as 15% of all FW-190s produced were destroyed or heavily damaged in non-combat accidents, primarily during takeoff or landing. Not from enemy fire, but from pilot error during routine operations. Thousands of aircraft lost, hundreds of pilots killed or maimed before they ever saw an enemy. It was a silent, grinding attrition that the Luftwaffe could ill afford. The second flaw revealed itself a week later, on March 29th. The objective was to test the aircraft's performance at the edges of its flight envelope. Reynolds took the FW-190 up to 20,000 feet, the Ohio landscape a patchwork quilt far below. He pushed the throttle forward, accelerating to the aircraft's maximum speed at that altitude, the needle touching 410 miles per hour. Then, he hauled the stick back and to the right, pulling the fighter into a tight, high-G turn, simulating a maneuver to get on an enemy's tail. The plane responded beautifully, biting into the turn with an agility that still impressed him. The G-forces pressed him deep into a seat, the world outside becoming a gray-blue blur. And then it happened. Without any warning, no pre-stall buffet, no telltale shudder through the airframe, no mushiness in the controls. The left wing dropped with sickening violence. The nose pitched down, and the aircraft snapped over into a vicious spin. One moment, Reynolds was in controlled flight. The next, he was a passenger in a falling, spinning machine, the ground rushing up to meet him. Reynolds was a test pilot for a reason. He fought the instinct to panic, forcing himself to go through the recovery procedures Jensen had briefed him on. Power to idle. Controls neutral. Opposite rudder to the direction of the spin. The FW-190 fought him, spinning for what felt like an eternity. Finally, after losing nearly 8,000 feet of altitude, the rotation slowed, and the nose came up. He was flying again. When he landed, his face was pale, and his flight suit was damp with sweat. He met Jensen by the hangar. "Art, it gave no warning," he said, his voice strained. "None whatsoever. No vibration, no signal. Just an instant, total loss of control." Jensen understood immediately. The FW-190's wings, much like the BF-109's, were designed for one thing: speed. They were thin and had a relatively sharp leading edge, which provided low drag but also a nasty characteristic: they lost lift abruptly and completely when the angle of attack became too high. In combat, this was a deadly trait. A pilot, focused on an enemy bomber, might pull back just a little too hard on the stick to tighten his turn and suddenly find himself in an unrecoverable spin, with no tactile warning that he was approaching the limit. Allied pilots had reported this for years, describing Focke-Wulfs that seemed to simply fall out of the sky during tight dogfights. The Germans had dismissed these reports as propaganda or pilot incompetence. Now, here was the proof, confirmed by a neutral engineering analysis. It was a fundamental problem with the aircraft's design. The tests continued through April, pushing the FW-190 in every conceivable way: maximum acceleration, service ceiling, dive speed, turning radius. In nearly every category of pure performance, the aircraft was exceptional, a true thoroughbred. But in the final phase of testing, the team uncovered the third, and perhaps most strategically significant, weakness, one that no amount of pilot skill could overcome. On April 14th, Reynolds took off with the fuel tanks filled to their absolute capacity, 138 gallons. His mission was to fly a simulated long-range patrol at an economical cruise speed of 280 miles per hour at 15,000 feet. For over an hour, he flew lazy circles over the American heartland, the drone of the BMW 801 a constant companion. He thought of the missions he'd flown in his P-47, escorting B-17s deep into Germany, flights that lasted for, sometimes 5 hours. After just 1 hour and 50 minutes, the red fuel warning light on the German instrument panel flickered on. Reynolds was shocked. He immediately turned back toward right field and landed with the tanks practically empty. Back in the lab, Jensen did the math. At a normal cruise setting, the FW-190A-8 had a combat radius of barely 400 miles. With a drop tank, it could be extended, but it was still woefully inadequate. It was enough for defensive missions, for scrambling to intercept incoming bombers over one's own territory. But it was not enough for long-range bomber escort. It was not enough for extended fighter sweeps over enemy territory. It was not enough to project air power deep into the heart of the enemy. The Allies knew this, even if they hadn't quantified it so precisely. It was the entire reason the P-51 Mustang existed. With its internal fuel capacity of 184 gallons and the ability to carry 2 108-gallon drop tanks, the Mustang had a ferry range of over 2,700 miles. It could fly from England to Berlin and back, with fuel to spare for fighting along the way. The FW-190 could never do that. It didn't matter how fast it could fly or how tightly it could turn. It simply didn't have the legs. And that was its third fatal flaw. The Focke-Wulf FW-190 was an outstanding interceptor, but it was a strategically limited air superiority fighter. It could defend the Reich, but it could not carry the war to the enemy. Arthur Jensen's final report, completed on April 30th, 1945, ran 218 pages, filled with graphs, data tables, and cool, objective analysis. It was the most comprehensive technical evaluation of a frontline FW-190 conducted by any Allied power during the war. Its conclusions were clear and brutally honest. The Focke-Wulf FW-190A-8 is a formidable fighting machine when operated by a highly trained pilot in a short-range, defensive role, he wrote in the summary. However, It presents three critical limitations that severely restrict its overall operational effectiveness. First, inherent instability during ground operations, resulting in a high accident rate among pilots with insufficient training. Second, abrupt stall characteristics at high G loadings without tactile warning to the pilot, making aggressive maneuvering exceptionally hazardous. Third, insufficient range for long-range offensive or escort operations. He concluded, "These limitations are not the result of engineering errors. They are the result of deliberate design choices that prioritized raw combat performance, speed, climb, and roll rate, over operational flexibility, strategic versatility, and pilot safety." The report was stamped top secret and filed away in the archives of the Technical Data Laboratory. Copies were quietly shared with British and American air intelligence officers. For the British, it was a technical confirmation of what their pilots had learned through bitter experience. For the Americans, it was something more. It was a validation of their entire strategic philosophy. The FW-190 didn't lose the air war because its pilots were inferior. Many of them were exceptional. It lost because the aircraft's design was a perfect reflection of Germany's flawed strategy, a focus on tactical defense and short-range interception. But the war wasn't won by defense. It was won by sustained, relentless offense. It was won by deep penetration bombing raids, by long-range fighter escorts that choked the Luftwaffe in its own airspace. The P-51 could do that. The P-47 could do that. The FW-190, for all its brilliant engineering, never could. Not for lack of power or armament, but for a lack of fuel, for an unforgiving nature that killed its own pilots, and for a design that chained it to its own airfields. Arthur Jensen went on to a long and distinguished career with NACA and later, NASA, contributing to the X-plane programs that pushed the boundaries of flight. His report on work number 737913 remained classified until 1978. When it was finally released, aviation historians hailed it as one of the most important technical analyses of the Second World War. It wasn't written by a victor trying to justify a victory, nor by a loser trying to explain a defeat. It was written by a neutral engineer who simply measured the machine and reported what he found. The truth without propaganda. The numbers without bias. The fatal flaws without excuses. The FW-190 was an exceptional aircraft, but it was an exceptional aircraft that helped lose the war. And its most important secrets were uncovered not in a swirling dogfight over Germany, but on a quiet runway in Ohio, by an engineer